Hey guys, welcome back to Voltage Learning. Today we've got another circuit, one with a current source and one with a voltage source. And we need to find the voltage across R3, the resistor in the middle. Let's walk through this problem step by step and figure it out in 4 simple steps. So in step 1, we first need to identify all the nodes and the voltage we need to find. We need to start by picking a reference point. The bottom of the circuit is ground or 0 volts. The point where R1, R2, and R3 all meet, we'll call voltage node A or V sub A. That's where everything is going to be calculated, and VA is also equal to the voltage across R3. Next, we establish the 3 main currents I1, I2, and I3. We apply Ohm's law to all the branches, so I1 equals 5 volts minus VA over 100 ohms. I2 equals 5 amps, since that's already provided to us. And I3 is equal to VA over 100 ohms. Next, in step 3, we apply Kirchhoff's current law at node A. Think of node A as a busy intersection. The 5-volt battery is trying to push current in through one of the intersections. The current source is sucking current out through the other part of the intersection. And R3 is letting some of the current leak to ground. So this all must balance. And when we do find a balance, we can write an equation. 5 minus VA over 100 equals 5 amps plus VA over 100. Finally, in step 4, all we have to do is simplify and solve using our calculator. We multiply both sides by 100, meaning 5 minus VA equals 500 plus VA. Therefore, 5 minus 500 equals VA plus VA. And this simplifies to VA equals minus 247.5 volts across R3. And that's pretty much it. We've solved this problem step by step and breaking it down into small digestible components. So if you want more circuits, tutoring, help, or interview practice, visit us at voltagelearning.com and don't forget to like, comment, and subscribe. Until next time, we'll see you guys later.